I've just finished making this rainbow fidget spinner and I reckon it's a perfect way to learn soldering and basic electronics. So we have here our kit for the Vorpal fidget spinner maker kit. This is of course open source like all the other Vorpal products, but they do have a handy package where everything comes together. And the reason I'm making this is it looks like a little bit of fun, and I think it's also an ideal project to show you the basics of soldering. I reckon it's an ideal first project for a student or a child who wants to get into electronics. Now before I do any soldering or assemble any of this hardware, you need to 3D print the parts. So you might notice there I have a very close to brand new PRUSA i3 Mark III, and it was one of the first prints that I did. I headed over to Thingiverse, downloaded the files, need one of each apart from the end caps where you need two. Then I printed it in the grey that came with the printer and it turned out pretty good. Cue time lapse now. Alright, so I stuffed up and my camera ran out of battery towards the end of the time lapse, but I did manage to film the oh so satisfying part about the Mark III, where you flex the build plate to get off the parts without a scraper. How good is that? Almost worth getting the printer for that feature alone. So here are the parts that make up the kit. We have two end plates which are close to identical, except one has a broad slot and the other has a narrow slot. We have our centerpiece, and on the inside of that are the cavities to hold all of the parts. And then we have our two end caps which are going to slot into the bearings. Probably a good time to empty the contents of this kit bag and see what's inside there. So we have a coin cell battery, CR2032. We have our skateboard bearing, 608. We have one piece of hookup wire, which might look like solder, but it's not. It's a little bit stiffer, and trust me, if you put it on your soldering iron, it will not melt. We have the coin cell battery holder. We have our heavy little weight, which is going to be the lever to activate the centrifugal switch. We've got our 5 LEDs in 3mm size. We've got our PCB. We've got some bolts, hardware. We've got some nuts, which I think are used for ballast. And we seem to have another set of LEDs. So without further ado, let's get started. The first step calls for us to solder the LEDs into the PCB. So for that, I have my soldering iron and it's heated up. And a couple of accessories that I really recommend to go with a soldering iron are one of these. It's like steel wool, but I think it's copper and it's excellent for cleaning the tip. I like to use this high quality one, which you get from JCar in Australia. The other essential for through-hole soldering is a set of wire clippers to cut through the leads after they're soldered in place. One little bonus that you don't always need to use when soldering, but it's recommended by the instructions and I entirely agree, is some flux. You can get flux paste like in the wiki from Vorpal. In this case, I've got a flux pen, which is exactly the same thing. It's just ultra convenient and neat. And now we're going to empty our 5 LEDs. You'll notice that there is a long and a short lead. And in our case, we want the long lead to be on the positive part of the PCB, which you can see is marked there, positive and negative. What we're going to do is to place them one at a time from the side without the copper, because we need to solder on the side with the copper. And the long lead is going to be on the positive side. So once you push it through, spin it around and make sure you've got that right, and do that for all 5. So I've placed this sub-assembly into the middle plastic part, and they recommend that in the instructions to keep everything even. It's working not too bad. An alternative is to get a little bit of masking tape and put it along the caps of the LEDs, and that should hold everything in place as well. Okay, so my soldering iron is heated up and I can test that by what we call tinning the tip. And that's simply when you get some solder and you touch it on the hot tip and it should melt instantly. This puts a small coating on the tip, and then I can clean it off straight after, and it should be nice and glossy and shiny after that. You would have noticed some fumes coming up then. Probably the best tip I can give you is to work in a room with ventilation, but if that's not possible, as you're soldering, the smoke will of course travel straight up. So lean over to one side, and then the smoke will go past your head instead of into your lungs. I've set up my close-up camera here because I want to give you a really good view of what you need to do for soldering. It should be a simple job, but it's very commonly butchered. People have a misunderstanding that they need to melt the solder to the soldering iron, but that's not the case. The solder will flow to whatever the hottest part is, anything that's hot enough to melt it. So what we're using the tip for is to heat up the components we're trying to solder together, and then we're meant to apply the solder to those. Let me show you what I mean. When I place it here, I'm trying to touch it evenly on the PCB and the leg of the LED coming through. I'm going to leave it there for a few seconds, and now when I apply my solder, I'm putting it on the opposite side, and you can see it made a perfect little shiny volcano there. Volcano in shape, of course, being what I mean. And we'll do it on this next one. So I'm putting the soldering iron equally against the PCB as well as the leg of the LED coming through. And after it's hot enough, I simply have to touch it on here and it will flow directly to the part and once again leave behind that perfect little volcano. This is what lots of people do. They put it here, they don't leave it time to heat up, and they melt it and they have a big glob stuck to the tip of the soldering iron, and obviously that's not actually attached to anything, so that's pretty disastrous. Let's do it one more time the right way. Heat up both components, bring the solder over, and it flows exactly where it needs to flow automatically. It's very important not to get any bridges in between the positive and negative side of this. That's when you manage to heat up both sides and have the solder flowing across here to here. It's what we call a short circuit, and that's going to stop the whole thing from working. I'm going to continue with the rest of these joints. Now what I didn't demonstrate there is the flux pen. This is pretty good solder, so it flows nicely, but what you'll find if you're, say, unsoldering and resoldering an old joint, the flux will help tremendously. Putting it on there, it burns off and it creates a gas layer around the solder joint, and that stops contamination and helps the solder flow a lot easier. So with one of these pens, we'll give it a shake. I'm going to spin this around so the camera can see it better. And you need to push up and down, and it's a little bit subtle to see, but the liquid will come out and it coats those components. Now this should be even easier than before to solder. Just to demonstrate how this works, I'm going to feed in the solder a little bit too early on this one, and then as it heats up, you watch it flow and stick to the bits that we want it to. There goes the flow. And one more time. And flow. Beautiful. It went up the tip of the lead. Okay, we have a little bridge between these two, simply because I put too much solder. And this one is what we call a dry joint here. It's not actually touching the lead. So knowing what we know, I simply need to heat up the component that I want it to flow to, and it should fix itself. This is not actually a bridge here because it's all the same circuit. This is all negative on this side and all positive on this side, so these two can stay touching. It's not a concern at all. Apart from that, everything else looks good. I've removed the coin cell from the packaging because it's time to test the soldering of our LEDs. We have this piece of hookup wire here, and what we're going to do is to put it through one of the sides. For me, I'm going to put it through the positive side and just wrap it around. And then I'm going to take the battery. You can see the big flat shiny one is the positive, which means the underside smaller side is the negative. I'm going to push that carefully against the negative. And then I am going to touch my hookup wire, and we should see that all of our LEDs light up and do their job perfectly. So I know I've done the correct job, and it's time to snip all of the leads short. Just remember that you're trying to cut them only after testing and as short as possible. We're going to take our finished LED array and we're going to put it inside the 3D printed housing. So it faces down. That means the LEDs will poke through the other side. And then the next component we need is a little centrifugal switch. If you shake it next to your ear, you can hear it clicking. I'll try it next to the microphone. Hopefully it's picking that up. And if we rotate it around, we'll see there's a little spot for it. I'm just going to rest it here for now. And from this hookup wire, we need to segment enough to go from here to the negative pole. So the first thing I'm going to do is to wrap it and solder it around the negative pole for LEDs. And then I'm going to solder to here and then cut off the excess so I can use it to complete the rest of the circuit, which is going to the coin cell and then the coin cell to the positive of the LEDs. Now I want this wire to come out as flat as possible to match the inside of the fidget spinner. So I'm going to do a little trick here where I heat it up, and while it's molten, this wire will become flexible. I can then cool it down before it burns my fingers, and now you can see it's coming out flat, which means it's going to sit really nicely inside of here. I'm going to bend it around that internal circuit, and I think if I cut it right there, I should have enough to solder to the top and a little bit spare to cut off at the end. Just need to give it a little right angle with the pliers. Now when you're soldering really fiddly things, there's a really handy tool called a third arm. I've got one just here. What it basically is, what it holds together, is a set of alligator clips and a magnifying glass, and it can hold two things close to each other to allow you to solder like having a third hand. So normally you have one hand on your solder, one hand on the soldering iron, and that leaves you with no hands left to hold the parts. If you don't want to buy one of these, because you're not going to solder enough, there is a great substitute, and that is blue tack. I don't know what it's called elsewhere in the world, but in Australia we use this to stick posters up to walls. You could probably use Play-Doh or plasticine or anything else. We're going to stick it down. So that's going to face to the side. That's going to face this way. Clean my tip. I'm going to pre-solder the tip of the centrifugal switch. You can see I've got a nice blob on there, which means now I can entirely use this hand for holding this here, heating up both, and they should flow together. Just hold it very carefully while it cools down and sets. And after it does, they are joined and I can cut off the excess. One important note for this centrifugal switch is we have a positive and negative for it, and one of those is the little lead coming out the bottom, the other one is the actual body itself, so make sure you don't bend it so they touch each other or it'll short it, and it's the same as the power always being on, as if the switch didn't exist. Let's do a quick test fit. Okay, that looks like it's going to be nice. Now our hookup wire, we now need to solder to the other side of the drum. I'm going to attempt to do it on the bottom. And to do that, I'm going to bend a tiny bit of this to a right angle. I'm going to knock this back out. I'm going to orientate it the right way. Get my blue tack once again to hold it in place. And I'm going to pre-solder the tip of this to save one hand later on. And now because this is a much heavier component, I need to apply more heat on it than I do this tiny bit of hookup wire. So So I'm going to start heating up this switch. It says in the instructions that it's quite tough compared to LEDs. A lot of electronical components, if you get them too hot when you're soldering, they can fail. Oh, I seem to have melted this while I'm gas bagging. I should just be able to dip this in. Hold it very steady while it cools. Okay, the good news is solder cools really quick, so I don't have to wait too long. That looks reasonable, apart from all the blue tack covering the top of this component. Oh dear. Fortunately, I have just the tool for this job, and that is an old gross toothbrush. Superb, just like it never happened. Let's put this in place. See that that's going to fit. It's going to need a little bit of pressure to push in, so I'm not going to do that quite yet. I still want to be able to pull it out just in case. But I will lead this wire down the internal channel towards the coin cell section, because I believe that's the next thing we're going to solder. The next component we need is the battery holder. You'll notice it's got one side with a positive on it. When it sits in place, that positive side is going to face up, and that matches what's printed into here. Now, once you've got it orientated that way, you'll notice there's 3 terminals on it, and the one closest to the middle needs to be cut off. You can twist it out of the way, but there's a fair chance it's going to short circuit. So I've got some nice flush cutters here. I'm going to put them at the base. Gone. Not sticking up at all now. Safest way to do it. Now in terms of the wiring in our fidget spinner, our loose wire that's coming from the centrifugal switch is going to come to the center terminal, the one that's lower than the others on the opposite side to the plus, and then our remaining terminal is going to go to the positive of the LEDs. So let's get that done. So the instructions recommend wrapping the end of this wire around the terminal. So I've used my pliers to make a little U, and then I'm going to put it in position. I'm going to squeeze it as tight as I can, and it's fallen straight out, of course. Might keep trying until I get this right. There we go. At first you don't succeed, pick this up and try again. Clean my soldering iron. Spin this around so you can see. I think that's plenty of solder on that. And then I'm going to get my pliers and just move this one so it's coming away from this other terminal. I don't want any chance of this and this touching inside the circuit. One part left. You should have some hookup wire left, and it should be probably twice what you need. But just to be safe, we'll do it one step at a time so we're not wasting any. Once again, I'm going to get my pliers and fold this around on itself, making a little U. Going to wrap it around the other terminal of my battery holder. Well, I'd like to, but it doesn't want to play ball. There we go. Going to get my pliers and squeeze it down on itself. Going to bring back my trusty blue tack to hold the corner of this in place, and now I'm going to proceed to solder it. Second last joint. That ought to do it, and I'm going to twist this one straight because it's going to be coming out that direction. Let's put everything roughly into place to make sure I've got the lengths of the wires correct. That one is going to slot into there with a little bit of difficulty perhaps. There we go. I can see I need to twist this one around a little bit just to be able to feed it into the correct place. Use the pliers to bend it. There we go. And I can leave just a little bit extra. Cut that there. Use my pliers to do a fold. I prefer to solder away from the 3D printed parts. You might prefer to do it in place. Get lots of heat into that PCB. And that should be our soldering done. Let's pop this back out and get our coin cell battery, positive and positive, both facing the same way. When you first put it in, nothing should happen at all, not until our switch is working. And if I do this fast enough, you can see they start to light up, but an easier way to test the circuit is to bridge with the remaining piece of hookup wire, or anything metal really, across the two sides. And that acts as if the switch was activated, and we can make sure everything's wired up the correct way, which it is, thank goodness. I think it's now time to push this permanently into place. By far the hardest bit to push in is the centrifugal switch. So what I'm gonna do is to get something flat, and I'm gonna apply my force evenly and push it down from the top. Hopefully something not too hard, so maybe this toothbrush can come in handy again. There we go. Take the time to go around and make sure you don't have any wires sitting proud of the 3D printed part. You can see here one of mine is sitting up just a little bit too high. So I'm going to flex it to create the extra length I need, and then use the pliers to very carefully push it down into position. I definitely do not want to short the battery, so I don't want to touch the plier tips in between the two terminals of the coin cell holder. And that is giving me the length I need for this to sit a little bit nicer, that being the PCB for the LEDs. This marks the end of all of our electrical work, so now we can finish the other mechanical parts. We're going to start with our 608 skate bearing. And you'll notice on one side of our assembly that the LEDs sit proud. So if we're pushing onto the table to put the bearing in, make sure you don't crush those. Therefore, I'm going to do it from the side with the LEDs facing up. Mine's actually a tiny little bit loose. So the instructions suggest in that case you can put a tiny drop of super glue there to hold it in place. And conversely, if yours is a little bit tight, you can just get a little bit of sandpaper and open up your cavity. Our other mechanical components are these nuts in the bag. They're used as counterweights. Obviously, certain corners of this are heavier than others, so the battery is going to be the heaviest one. And then we have our little switch, that's probably going to be the lightest. So what we're going to do is put these nuts into place, and that's a beautiful fit. And the more balanced it is, the longer it will spin for, and the less vibration and energy will be lost from that vibration. Alrighty, with those balanced in there, it is time to put on the two external faces. The 3D printed patterns face outwards, and we have a large cutout to go over the LEDs, which means since the nuts, we don't want them to fall out, we're going to actually put on the one with the narrow slot. I'm going to do that one first, so we're going to line it up with the LEDs. You should just be able to see them shining through from underneath. And I'm going to get this one in position on the other side. That way the LEDs won't be poking through proud anymore, and I can rest it on the table without damaging them. Let's open these bolts. And we need a 2mm Allen key for this job. I believe we'll be cutting the threads as we go, so we need to push inwards and make sure it stays really straight at the beginning. Okay, slight problem for me, and I could probably predict this was coming because I have a little bit of under extrusion and my bearing needed super glue to stay in. I have the same problem here, and that's that there's not enough plastic to catch the threads and have this screw in. So I'm going to use my super glue once again, just to bail me out. And squirt a little bit down each of these holes. And once this sets, it should be ideal for the nut thread to cut into and make this a lot stronger. I'm going to try not to get this on my fingers because probably like most people, I'm pretty good at super gluing my fingers together. Personally, I'm going to have to wait a little bit of time for that glue to dry, but all that remains is a mere 2 parts, and they should be really easy to do. That is the 2 caps. Hopefully you remember to print 2 when you printed them, and they are an interference fit. You can see they've got this part here that can flex in to make sure it's really tight, and you put one either side and simply squeeze together with your fingers, and that is your assembly complete. So let's test this thing out. Excellent, works perfectly. It's a simple circuit, but it's a pretty cool thing in the end. I mean, there's a lot of fidget spinners around, but it's not really as satisfying as when you do it yourself. The camera doesn't really do it justice. The way that the camera takes frames and captures everything, it looks like it's jerky, but in real life it's a continuous smooth light that comes up. I'm gonna have to test this at night. If you have the other Vorpal product that I have, which is the hexapod, there is a fidget spinner challenge included in this. Now this fidget spinner complements that perfectly because it needs 2 to 3 RPM before the lights come on. So what better way to verify whether you're actually doing it correctly with the robot than to wait till the lights come on and know that you've hit the minimum threshold. Stay tuned if you'd like to see a video on how to modify this file on Onshape and 3D print your own custom one. In the meantime, thanks for watching. See you next time. G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.